Welcome to Lesson 89, Diagonals and Angles of Polygons. Our objective is I can find the diagonals and angles of polygons. So a diagonal of a polygon is a line segment that passes through the polygon between two non-adjacent vertices. So let's draw a really quick polygon. Here's one with 4 sides. And let's draw a diagonal. Let's see, A, B, C, D, and I'm going to have to draw it from A. And the only diagonal I can draw that's not originally a touching A, right, is from A to C. This is the only diagonal in this polygon I can draw. A to D, right, the line segment AD is already an edge, and the line segment AB is already an edge. So the only other one I can draw is AC. So from a single vertex, how many diagonals can be drawn from a hexagon? So I'm going to do it through A again. AB is already a line segment, right? It's already an edge, so that can't be a diagonal. So I'll draw from A to C, draw from A to D, and I'll draw from A to E. I'm going to blow this up because now we want to start thinking about the interior angles, mainly these guys right here. These angles on the inside of a polygon are called the interior angles. So you may ask, and I may ask, what are the measurements for each of the interior angles? And what we're going to do is a little bit clever. So let's get those angles away and let's figure them out. So do you see that each diagonal here, right, AC, AD, and AE, they all divide up the polygon into triangles. So I have triangle 1, triangle 2, triangle 3, and triangle 4. So now that I have those triangles, we remember that the angles of a triangle add up to 180 degrees. So the angles in triangle 1 all add up to 180 degrees. The angles in triangle 2 also add up to 180 degrees. The angles in triangle 3 add up to 180 degrees. The angles in triangle 4 add up to 180 degrees. So the interior angles for the whole triangle will be the sum of, for the whole polygon will be the sum of all of the angles for the triangles added up. So 180 times 4 is 720 degrees. Okay, you with me so far? I'm going to do this inside of a circle because I can. So if I were to ask you, find the measure of each angle of the regular hexagon A, B, C, D, E, F. So draw the angle of find the angle measure of each one. So for instance, what is the measure of angle A? Well, we saw before that we divided it up into 4 triangles. 1, 2, 3, 4. We have 180 degrees plus 180 degrees plus 180 degrees, 180 degrees. Well, we found that all of the angles, all of these guys in the hexagon all add up to 720 degrees. That means that they have to be divided evenly. All of those 720 degrees have to be divided up evenly between all of these interior angles. How many of them are there? 1, 2, 3, 4, 5, 6. So let's divide 720 degrees by 6. And when we do that, each angle will be 120 degrees. So this angle will be 120 degrees. So will this one. So will this one. So on and so forth. Okay. Go ahead and pause the video and try to find all of the interior angles on your own. Now that you've tried it on your own, let's do it together. So I'm going to pick one of the points and I'm going to draw diagonals, all the diagonals I can. Looks like I can do it twice. I have triangle 1, triangle 2, and triangle 3. So the angles in triangle 1 will be 180 degrees. The angles in triangle 2 will be 180 degrees. The angles in triangle 3 will be 180 degrees. Then I can add them all up. 3 times 180, if I'm not mistaken, is 540 degrees. Let me double check that on my calculator. 180 times 3 is 540 degrees. So they have to be distributed equally amongst all 5 angles, right? Angle 1, 2, 3, 4, 5. These interior angles right here. So 540 degrees divided by 5 is 108 degrees. Each of these interior angles is 108 degrees. Go ahead and try this one on your own, and I'll see you in a second. Now that you've tried it on your own, let's do it together. So we want to draw some sort of quadrilateral and one of its diagonals. What is the sum of the measures of the interior angles of this quadrilateral? Well, I can make 2 triangles. Triangle 1 is going to have 180 degrees. Triangle 2 is going to have 180 degrees. So if I add those together, I'm going to get 360 degrees. Then I need to divide up those 360 degrees across all 4 interior angles, and I'll get 90 degrees. So, if you actually read the question, Mr. Bibb, then you'll actually see that it wants the sum of all the measures of the interior angles, which is just 360 degrees. So now let's start thinking about the angles on the outside. So usually when we draw one of these, this is a hexagon, there's 6 sides, so it's a hexagon. When I walk around a hexagon, I turn left and I go, then I turn left again, and I walk some more and I turn left, then I walk some more and turn left again to get all the way around. But what happens if I don't do that? What happens if I just don't turn left and I just go straight? What was the amount of the turn that I should have done? Well, we call that the exterior angle. The exterior angle. It's the amount of walking that we should have done, or the amount of turning that we should have done while we were walking. So these are kind of cool. These are kind of cool. And the reason that they're kind of cool, if we always turn in the same direction, right? I'm always turning left, then I should have gone all the way around, which means I should have turned 360 degrees. And that will be true for any polygon, right? If I take a square, and I should have turned 90 degrees here, I should have turned 90 degrees here, I should have turned 90 degrees here, should have turned 90 degrees here, then all of the exterior angles add up to 360 degrees. I'm going to color all of the exterior angles to help show my point. Here they are. They're there in the light blue. So these are all the exterior angles of a regular hexagon. We want to know, what is each individual one? Well, they all add up to 360, right? Should have gone all the way around in a circle. But there's 6 angles, right? 1, 2, 3, 4, 5, and 6. So each individual one is 60 degrees. Each individual one is 60 degrees, and that's how we find it. Thanks for watching. I'll see you in the next video.